All right, let's get right into it. These notes are on ecological succession, and the information can be found on pages 168 to 171 in our Friedland text. There's Gary here. I got you a treat, Gary. All right, let's get into this thing, yeah? Okay, so in ecology, change is inevitable and it's ongoing. These changes can be caused by disturbances. Some of these disturbances can be anthropogenic due to, let's say, chemical agents like oil spills, lead, mercury, radioactive material. We can also have biological disturbances too, like invasive species or disease. And we can also have physical disturbances like floods, fires, hurricanes, landslides, earthquakes, and volcanoes. In fact, we just saw some physical disturbances here in Hawaii recently. Let's take a look here. I found this video on CNN. Hopefully it plays. We're seeing some of the results here of lava flow coming from Hawaii's Kilauea volcano. It erupted May 3rd, and pretty horrific devastation. Imagine seeing this as your backyard view here. Not too fun. So a lot of devastation here to the living plants, especially any animals that might be in the area. Pretty awful. What happens, though, is that this ecosystem will very likely be able to rebound, and how it rebounds is called primary succession. That's what we're going to talk about right now. So let me go on. I just had a couple more photos here. So this is where that was happening. Kilauea in Hawaii. You can visit now Volcanoes National Park in Hawaii, one of the only places, and I think the only place in the world where you can see flowing lava. Pretty wild. There's a shot there of Kilauea. The devastation that it is brought to the area. I don't know why she's smiling. This might have not have been part of what was just happening this last summer here. Pretty wild. So all of that rock right there, that bare rock, will eventually, might take hundreds, thousands of years, will eventually give way to new life, soil, new life plants, and eventually animals too. Primary succession could happen on newly cooled lava. It can also happen on the bare rock that you might see when a glacier retreats. Take a look at the picture on the left, the picture on the right. You can see how this area here has vegetation on it. So we might have seen some primary succession occurring right in that area after that glacier, that ice has pulled back to reveal bare rock underneath. Okay, so let's get into this here. So the word succession refers to a series of environmental changes to an ecosystem. And there are a couple types of succession that we're going to talk about. Primary succession, secondary succession, and then we'll get into just a little bit on aquatic succession. Primary succession occurs only on bare rock, brand new bare rock, right? Maybe that bare rock is there because of a glacier that has retreated or melted away to reveal it. You also might see bare rock or new rock on newly cooled lava as well. Primary succession is going to occur where there is no soil. All right, so it could even happen on, let's say, an abandoned parking lot too. All right, so this is the process of primary succession. It occurs again, it starts on bare rock, and that bare rock will be colonized by algae, lichens, moss, these plants here, these photosynthetic organisms that require little to no soil. And what they do is they secrete acids that help to erode the rock over time. And those minerals in the rock, along with the dead and dying lichen, algae, and moss that came before it, are all going to kind of mix together and to create this new primitive soil. It's going to be nutrient poor, but as time passes and this process continues, more and more soil will develop, which will be more hospitable to plants and with roots. I forgot that I put numbers in here. So there was one that starts with exposed rock. Then we've got lichens and moss. So those guys require little to no soil. They get in there, start breaking down the rock. Over a long period of time, we might start to see some primitive new soil. Mid-successional plants like grasses and wildflowers, these guys that come in and are dispersed by wind, and seeds are going to start to take root in that new soil. These mid-successional plants are well adapted to exploiting wide open spaces with a lot of different sun, and they're able to live in that nutrient poor soil. Over time, these plants and wildflowers are going to die. The decomposers recycle their nutrients back into that soil, which increases the soil's fertility and also the soil's ability to retain water. Therefore, that's going to be more attractive to new species that might even be able to outcompete the others, like those shrubs and eventually the aspen, cherry, young pine forest, which will give way to new species that are able to maybe outcompete those younger, smaller trees as they reach up and try to photosynthesize taller. So that's primary succession. It starts on exposed rock, and then just over time, plants, taller and taller plants, more resilient plants come in and replace the ones that came before. Just wanted to point this out here. So the type of community then, the picture that we were looking at before is a temperate seasonal forest, kind of like that story that we read in the very beginning of chapter 6. So the type of community, though, you might not always see those gigantic trees, right? The type of community and the richness of the species in the area is determined by temperature and rainfall, which is ultimately determined by the latitude of where the ecosystem is located. Time is also a factor because it gives more opportunity for speciation between the different organisms. So the longer the community has been around, the more rich in species it will be. All right, so here's an example of primary succession. Krakatoa in 1883 in Indonesia, a big volcano erupted and killed a bunch of stuff, all the plants area, animals in the area, laid out a bunch of ash. And, over the past, 50, 60 years since 1883 up, they began to see these different plants that were able to establish themselves throughout the year, getting taller and taller until we get forest. In fact, the area that was destroyed by Krakatoa in 1883 is not yet done with the primary succession opportunities available, and it's still continuing to develop even to this day. All right, so what I recommend is pause the video right here. I want you to find the article that we read in the very beginning of chapter 6 on New England forests come full circle and read it again. This will outline secondary succession. Push pause. I'm assuming you pushed pause, you're back, hey. So here's that picture there that you saw in that article. This is a wall that is kind of the only remnant that remains of the settlers that came in and took out all of the plants so that they could farm in this area. They abandoned them. And we've got this kind of hint of what used to be with the settlers that came before. And over time, secondary succession took root. Why not primary succession? Well, because it wasn't bare rock at the time. There was soil. In fact, the soil was being used for agricultural purposes, right? That's one of the biggest differences with primary secondary succession. Take a look here. So, take out the pictures of the bare rock, the lichens, and the moss, and you have secondary succession, right? Wildflowers and grasses, these small seeded plants that can be dispersed by winds and birds will take root. They will likely be outcompeted by other slightly larger ones. In the story, it talks about the goldenrods that came through. If there's enough rainfall, trees might even begin to replace the grasses and the small shrubs. The first tree species are those that have small seeds that can be carried by the wind, like the aspen trees, or the seeds that can be carried by birds, like the cherry trees. And I've marked this in our picture as a pioneer species. These trees, though, start to crowd each other. They'll start to block out their light. They'll give rise to more shade-tolerant trees, like the beech trees and maple trees, in the case of this temperate seasonal forest. They'll outcompete the pioneer species. This process will happen on large or small scales. In fact, it could happen when a tree dies, very small scale, right? Opening up an opportunity, more light coming in for smaller plants or seedlings to take root and take advantage of the light as the process continues. Aquatic succession. Succession could happen in a lake. Let's say a glacier recedes and a lake forms. What will happen over time is that through erosion, sediments, organic matter, things die, will start to fill in on the bottom of the lake and making it shallower over time. What happens is it will eventually, after hundreds or thousands of years, become potentially a terrestrial habitat. So succession could happen in ponds and lakes too. All right, so make sure that you can describe the differences between primary and secondary succession. Make sure that you can explain the general processes of primary, secondary, and aquatic succession. And then make sure that you know how species richness is determined. Thank you very much for watching. How'd I do, Gary?